Bismillahirrahmanirrahim. In this video, we'll solve practice problem 15.12 from the book Fundamentals of Electrical Circuits. Okay, now this is practice problem. Graphically convolve the two functions given here, x1t and x2t. Okay, so these were the original signals. Now the first step, as we have been following, is that you change the scale from t to lambda. So this t variable will be changed to lambda, and this is done because in subsequently solving this problem, we'll be using t as a variable itself. So this is how it looks like after the change of t into delta, and the name also changes from x1t to x1 delta, x2t to x2 delta. The next step is to flip one of the signals around x-axis. So either we flip this signal or we can flip the other signals. Since this one is simpler looking, so it is better that we flip this one. So we flipped it towards the left. So the scale is now, this is 0 and -1, and the name also changes from x1 lambda to x1 minus lambda. The third step is move the flipped signal to a point t. So we'll move this to a point, any arbitrary point t, and what really we'll do is that we'll change 0 into t like here. So the 0 is t, or t is added to 0, and similarly a t is added here, so it is t minus 1, and similarly a t is added here, so it is t minus lambda name. And now we'll move this signal or push this towards the other signal. So let's see. So we have pushed it enough to bring it very close to the other signal, but still there is some gap. There is no overlapping between the two signals. So we'll call this movement of t as the movement of t up to 0 or less than 0. And what actions did happen? Okay, we'll be using this integral formula throughout. So since there is no overlap, now this shows the overlap between two signals, and since there is no overlap, therefore this term will be 0, and so our output will be 0 for t less than 0. Now in the next step we'll move it further between 0 and 1. Let's see, so we have moved it between 0 and 1, and will not go beyond 1, because the moment we cross 1 there will be a change in the situation. Now it is just ingressing into this signal, and so the area of contact between the two is gradually increasing till this t reaches 1. So let's see. So this is now the movement from 0 to 1. T is moving from 0 to 1. Formula same. Applied in our case now. Let's see the overlap. This is showing the overlap. Now from the two graphs, we can very easily see that this is the starting point. It is very clear from the upper one, but we don't know what is the starting point from here. So we'll take this as a starting point. So the starting point is 0. Similarly, the end of overlap we don't know what is the value here, but we for sure know that this is t here, so our end point will be t, and then the multiplication of the two signal x2 and x1. And now we plug in the values. Now this is also 1 and this is also 1. So plugging in the value of the two signals, integrating, we get lambda, then put the limits, two limits, 0 and t. So we get an answer equal to t. Okay, now we move it further beyond 1. So now it is between 1 and 2. And now, so the movement of t is from 1 to t, and the range of integral is, now you can see from here, this is the overlap. So it is starting from t minus 1, not clear from here but clear from here, so t minus 1. Similarly, not clear from here but it's clear from here, so the upper limit is t. So these are the two limits and the signals multiplying. And now if you see, these are actually, this can be broken down into two parts. This is one part where 1 is multiplying with 1, and this is other part where 2, this is 2, is multiplying by 1. So how do we divide the integral now? For the first part, it is from minus t minus 1 to, what is this point? We don't know from here, but for sure it is known here, it is 1. So the first part will be t minus 1 to 1, and the second part again from here, this is clear, it is 1, and from here it is clear the upper limit t. So let's write it, minus t minus 1 to 1, t minus 1 to 1, and 1 to t. 1 to t is the limit. Now in the first case, area multiplying 1 into 1, so 1 into 1, and in the second case, area multiplying is 1 into 2. And now if you solve it, lambda here, 2 lambda, put in the limits, and putting in the values, we get the answer t. Now we push it further beyond 2. So our range now will be t between 2 and 3. Between this, same formula. Now this is the portion of overlap. So what is the limit? You can see starting from t minus 1 and ending at 2. Not clear from here, so we'll take this 2. So t minus 1 to 2, the two signals, putting in their values, 1 and 2, 1 from here and 2 from here. And then integral comes to lambda, plugging in the values of 2 and t minus 1, we get the answer 6 minus 2t. And now finally we have pushed it beyond 3. There is no overlap between the two signals, so output will be 0. So the range greater than 3, no overlap, so output is 0. So let's summarize now. This is the result that we got for all the different ranges of t. And now we could plot this. Let's see, first one, t less than 0, it is 0, so we plotted this. Then between 0 and 1, so up to this, its value is t, so slope is 1, so it will be something like this, slope 1. Then from 1 to 2, again the slope is t, so it is same slope will continue from 1 to 2. So it will be like this from 1 to 2. And then now 2 to 3, we have a negative slope of 2 with y-intercept 6. So negative slope of 2 we have to plot from here. That means vertical 2 and horizontal it will go 1. So it will reach at this point. So, and if you extend this, it will touch 6 on the vertical line. So this is the y-intercept. So 6 minus 2t. And finally, for greater than 3, it is 0, this one. So we conclude that the final output will look like this, and 0. So I hope this gives you an understanding as to how to solve this type of a problem. Thank you.